In this project, we are going to do the regular maintenance to this 25 tons package unit air conditioner. There we have the foam cleaner, but we need to check the coils and see if they really need that pink chemical to be applied. Here we are at a Kier Motors agency. There's two 25 tons units, but the other one may need to be repaired. We have everything to do the job: the light pressure washer, multimeters, manifolds, and all kind of tools. One of the first things to do before the maintenance is to check for oil marks like these ones, which means the unit is leaking refrigerant. In cases like this, for example, the customer needs to be informed because we're talking about a repair and not just regular maintenance. By the time we are inspecting the unit visually, we need to check the performance too in order to find any trouble, like suction or liquid frozen lines, temperatures of return, and air supply to the building. The thermostatic expansion valve needs to be checked also. Once we checked visually and superficially how the unit is operating, it needs to be open to check how it's working inside before we do the job. That way we can compare the measurements before and after the maintenance or any kind of repair. Here, for example, we are checking the amperage, which is the energy that consumes per line this compressor. The label says that consumes 18 amps per line. We see in this case this line is consuming between 14 and 15 amps. Now this other one is consuming between 17 and 18 amps. And in the third one we got 15 amps, so let's say this compressor is consuming the average energy per line which is stated in the label. Now let's check the gas pressure while is working. As this compressor operates with our 410 a refrigerant, it must be between 120 and 140 pounds per square inch of pressure. This is the evaporator area where the coil filter's supposed to be. In cases like this we need to inform the user that they need to be bought or replaced because all the dust got stuck in the evaporator coil, reducing the efficiency of the unit. Now once the unit is off, we are going to check the fan motor capacitors. In this case they are 6, and in their label says that they should have 10 microfarads, 5% less, or 5% above that measurement. In this case they are in the correct range. As we can see, this one, for example, is oscillating between 10 and 10.5 microfarads, which means this capacitor is okay. Another very important thing to check is the supply blower fan and motor. The blades of this fan may be covered with a thick layer of dust. The rubber band that transmits energy from the motor to the fan needs to be checked because sometimes they wear and tear off by themselves while running. If there is any issue with the pulley, like is too loose or making noises, it can be pulled with a pulley punch to be fixed or replaced. Now this is what we talk about when we say the evaporator coil needs its filters. Here is where it's worth to use this pink chemical to help dissolve these thick layers of dust stuck in the coil. As we can see, here is a critical area where the heat transfer takes place, and all that dust works as insulation, preventing most of the heat to be pulled from the building or in a cold weather. All this dust prevents the cold air in the building to be heated, so the unit efficiency is reduced, which can be translated as more energy wasted, which means wasted money. The evaporator and condenser coils can be washed with a light pressure washer to remove all that dust we were talking about. The same goes to the blower blades and other parts of the unit. Here, for instance, we are using a 1,600 pounds per square inch little pressure washer, which pressure is just fine, so the thin coil lines don't bend. The entire coil need to be clean and free of any dust, and as we said in the beginning, once we are done with the maintenance, measurements got to be compared, the before and after. Here is a prime example of how nice and clean the condenser coils are after this regular maintenance. As we said, every other part or supplement that needs to be changed, it got to be changed to see and measure the unit performance. Here, for instance, we are checking the label that let us know the amperage of every component while the unit is working. What we do is add one to another, get a result, and compare it with every electric supply line. Now here, for example, this phase is consuming 28.8 amps. In this one we got 30 amps. And in the third one we got 34.6 amps. We are thankful for our customers' preference, recommendation, and trust. We also appreciate our page's followers for their likes, comments, and shares. Thank you for watching.